So just a minute, my device got stuck. Are you able to hear me?
Yes, sir.
Okay, just a minute, it got stuck. Yeah, now it is better. See, today we will be looking into some mathematical definitions of other terms that are there. So we saw the mathematical definition of surface tension, which is defined as the amount of force acting per unit length. So have this in your mind. Surface tension is equal to. So just because we see the word tension, many people think it is force. No, it is the amount of force per unit length that is acting on the surface of a material, right? So yesterday I told you one important point. What will the molecules in the surface do? Molecules at the surface, they will try to contract themselves so that they are able to occupy minimum surface area, right? So when that is happening, when every molecule has energy associated with it, can we speak about the energy of the particles on the surface as well, which is called as the surface energy, right? So here the definition goes like this. The surface of a liquid possesses minimum area. Why is it possessing minimum area? So as to have lesser amount of potential energy due to surface tension. To increase the surface area, see, if suppose you are interested to increase the surface area, what are you supposed to do? So when you are increasing the surface area, you are also increasing the potential energy. You're increasing potential energy means you're doing some work, right? I told you already, energy means work. So when I talk about the particles at the surface, these particles have less energy, due to which they have less surface area also. So what I'm asking is, if I have to increase the surface area, then what I need to do is, I need to bring the molecules from the interior to the surface. Will the molecules be able to move on their own? The question is it possible for the molecules to move from the interior to the surface on their own? Is there a possibility where on their own means, is it spontaneous? For example, I have a ball that is kept on the top of an inclined plane. If I ask you a question, is it spontaneous that this ball will come to the bottom?
Yes, sir.
What is your answer?
Yes, sir.
It's spontaneous. But what about the vice versa condition?
If force is applied means the ball will go up and come down again.
So if you apply a force, means if this ball has to go upwards, then it is not possible to happen naturally. Rather, we need to do some work. Right? Same as the scenario here. The particles in the interior have lesser amount of energy. It is not possible for them to move to the surface on their own. But if you have to make them move, we need to do some work. That's what they are trying to talk about. Listen. I'm repeating the statement. Listen here. The free surface of a liquid, possesses minimum area due to surface tension. To increase the surface area, molecules have to be brought from the interior to the surface. So if that should happen, work has to be done against the forces of attraction, right? We need to do some work. Okay. So when you do some work, it has to definitely get converted to some form of energy. So the work which we do is going to get stored as the potential energy of the molecules on the surface. So the molecules at the surface, what will happen is they will have extra energy compared to the molecules in the interior. That extra energy possessed by the molecules in the surface is what is called as surface energy. So how do you define it? The extra energy possessed by the molecules of the surface film of a unit area compared to the molecules in the interior is called as surface energy. So how do we define it? So this is the meaning of surface energy. Mathematically, it means it is equal to the work done in increasing the area of the surface film by unit amount. So please make a note of that point. Let me know once you're done. So write down the mathematical definition. It is defined as the amount of work done in increasing the area of the surface film by unit amount. Done?
So could you say the mathematical definition once again?
It is here, no? It is equal to the work done in increasing the area of the surface film by unit amount. The last sentence. Okay. So surface energy is written like this: work done by the increase in surface area. Please make a note of it. Work done by increase in surface area is what is called as surface energy. So what will be the SI unit of surface energy? It is joule per meter square. Okay. Am I clear till this point, guys? Now comes an important question. We have seen two terms in this chapter, that is surface tension and surface energy. Now comes another question. What is the relation between them? The relation between surface energy and surface tension. So what is it? Let's see. So before I explain this, I just wanted to show you a video. See, are you guys able to see?
Yes, sir.
Yes, sir.
See, there is a ring, okay, and there is soap solution present at the bottom. See what is going to happen. Are you able to see a film?
Yes.
So initially there was no film. When he dipped and took it out, there is a film that is formed. Okay. Now what will happen is he will try to draw a thread on top of it. Look what is going to happen to the thread. The thread is getting balanced, right? Now see, he will prick a hole. What happened? Did you see what happened? Now also. So I'll repeat it again. See, initially he's dropping a thread. Okay. Then a small hole is pricked. When it is pricked, what is happening? That black color hollow portion you're able to see, no? It is actually
Yes.
not thread. It is a surface like, I'll show you. So this is actually a hole. What has happened is the thread has got changed its shape such that it is able to occupy a minimum surface area. Okay, that is why it took a circular shape. Clear? Similarly, when he's dropping the other thread, so initially when he dropped the thread, it was something like this. When a hole was made here, the thread took a circular shape so that it is able to occupy the minimum surface area. And this is happening because of the surface tension. Okay, similarly, let's see what is happening to the other thread also. So what happened? Again, the film is formed back. Did you see what happened at the end? When he took out the thread, what happened? The film came close, and again that hollow portion became a complete round part. Right? The film filled the space. All this is happening because of surface tension, and the example for this is given here. Endless wet thread on a soap film. This is what has happened. Okay. Initially, when the thread was shapeless, right, the forces were acting like this. But when the hole was pricked, what happened? The surface tension started acting equally in all the directions. Okay. So with this context in mind only, we are going to derive the relation between surface energy and surface tension. So for that, what we are going to do is, we are going to consider a rectangular frame. See, for example, the video which I showed you had a circular frame. It's a ring which is dipped in a solution and taken out. Here, instead of ring, let's say you have a rectangular frame which is dipped in a solution and taken out. And there is a thread kept at the end. What do you think will happen to the thread? So there will be a film, right? Are you able to understand this part?
Yes, sir.
Initially, let's say it is like this. This is the thread. There's a rectangular frame. Right. Initially, it has no soap solution, like how the ring was. To understand better, I will show it to you. Like here, you have a ring, but no film, right? It is like that. Okay. Now, when it is dipped in a soap solution and taken out, a soap film is formed. So, what will the soap film try to do to this thread? The soap film will pull the thread interior. It will try to pull it inside. And let's say it is happening due to a surface tension T or sigma. Then, to maintain this thread in equilibrium, what are we supposed to do? So if I have to maintain something in equilibrium, what are we supposed to do?
External forces.
Yes. So you observe here, what is going to happen is, the sigma is the force that is happening due to the soap film, which is trying to pull the thread inward. And let's say the thread which was initially at A dash B dash has got displaced till AB by distance x. Okay. So what is the actual force exerted by the soap film? So the force exerted by the soap film is, yesterday I told you, surface tension is equal to force by length. So F will be equal to sigma into L. So F will be equal to sigma into L. But here I will multiply it with the 2 because the 2 represents the number of free surfaces. So here you're trying to talk about a soap film. Soap film has how many free surfaces?
2, sir.
It has 2. That is why I'm writing it as 2 into sigma into L. Okay. So that is the force that is exerted by the soap film. So I have written, it is mentioned here. See. Here the factor 2 is taken because the soap film has 2 free surfaces. suppose AB is moved out through a distance x in the position A dash B dash. What is the work done by the force? Work done by the force is equal to force into displacement. So try to understand, guys. A dash, B dash, AB. If this distance is x, surface tension is acting like this. Okay. So the force that is acting is 2 into T into L. Okay. So work done by force is how much? 2TL into x. Why did I write 2TL into x? Because work done is force into displacement. Right?
Yes.
Sir.
What is the area that has been covered? What is this area? What shape does it take, guys? Length is L,
L into X.
L into X. But here, area will be 2 times L into X because of 2 free surfaces. Okay. So, we know that surface energy is equal to how much? Work done by unit area. Work done is 2T into L into X divided by the area is 2L into X. So, 2Lx and this will get cancelled. You will get it as T. So, what is mathematically surface energy equal to? The surface energy is mathematically equal to surface tension. Guys, please make a note of these points. I'll be back in 5 minutes. Students, are you there?
Yes, sir.
Yes, sir.
Yes.
So, what were we discussing? Guys, actually, I'm not feeling well, okay? I'll not be able to prolong. I'll just finish this topic and we'll end the session for today. I'm not able to handle it, okay? I'm sorry for that, but I'll compensate it some other day. So, I just wanted to tell one last statement that the surface energy that you have copied, the surface energy of a liquid is numerically equal to its surface tension. Okay, that's what we have got, right? So surface energy, we wrote it as work done divided by increase in surface area. So the surface energy of a liquid is numerically equal to the surface tension. Clear? Is there any doubt till whatever we discussed till now? Is there any
So
point
on
that is
that
not?
area, could you explain again? 2Lx is
Yeah.
because we have 2 free surfaces, so we take area of one surface, area of the other surface, and add it. That's
Perfect.
what it
That's
is,
right.
sir.
That's right. That's right. That's right. That's what we have done. So when I say increase in surface area, it is 2 into L into X. And I hope you have understood why it is why work done is 2 sigma into Lx. 2 sigma into L is nothing but the force multiplied with the displacement will give you the work done. So 2 sigma Lx divided by 2 Lx will be equal to sigma. So have this point in your mind because this is very, very important for our other derivations. Okay. So next class we will discuss the remaining part. Okay, next class I thought of completing today, but I'm not able to handle. I'm sorry for that. Okay. So you guys just go through this document and prepare.
It is fine, sir.
Next class I will.
Take care.
Okay. Yeah. Thank you guys. Okay. I'll see you guys tomorrow.
The maths class is there, sir.
No, I can't handle it. I'm sorry. I'm not
Yes, sir.
able.
No.
Okay. I'm canceling it. Okay, you guys take care. You prepare. Okay. See you all tomorrow.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir. Take care, sir.
Thank you,
Thank you,
sir.
sir.
Take care, sir.